Welcome back to Maths with Mr. Duffield. I am the aforementioned Mr. Duffield, and I'm going through what I've talked about with my LE class this morning as part of our consolidation work. I thought I'd make a more formal video just to follow it up and work through it again. This question: the point C has coordinates 2, -3, and the point D has coordinates 4, 6. Find the equation of the line perpendicular to CD and that passes through point D. So there's a number of things that are going on here, and it makes sense that it's a question that you might need support with. But in essence, to break down how we're going to do it, we're going to find the equation of line CD. We're going to find the perpendicular to that line equation, and then use the point D to substitute in and work out that perpendicular equation. Now, I believe from the feedback that I've had that the answers you're provided with don't get this right, so you should watch this video as your first port of call, really, for this particular question on the sheet. So let's have a go. Point C is 2, -3, and point D is 4, 6. The gradient, as we've done before, is the change of y over the change in x. Remember, these are the x numbers here, and these are the y numbers here. What's happening to the y numbers? The y number is increasing by 9, and the x number, 2 to 4, is increasing by 2, making the gradient 4.5. So, y equals 4.5x plus c, if we subscribe to that being the gradient, and obviously y equals mx plus c. So far, so good. Now, we need to substitute in one of these two coordinates to this equation in order to find what that c is. I have chosen point D, but you can substitute in point C and you'd get the same value of this constant here by doing that. The reason I substitute in this D is because I'm scared of negative numbers. They give me nightmares. So, remembering that 4 is the x value and 6 is the y value, let's substitute them in. Y becomes 6. X becomes, x becomes 4. 4.5 times 4. That's 18. So, by taking away 18 from both sides, we should work out that C is -12, meaning that the line CD, the equation of that line, is y equals 4.5x minus 12. Okay? So far, so good. We found the equation of the line C, but we don't want the equation of the line, or the line CD, excuse me. We don't want the equation for the line CD. We want the equation for the line perpendicular to it. So that means we need to find the perpendicular gradient, or as I write, perpgrad. Okay? If we take the gradient as we found it above, 9/2, remember how we find the perpendicular gradient of anything. We find what we call the negative reciprocal. That will always be perpendicular to any gradient that we've got, as in meets at 90 degrees. What I mean by that is swap the top and the bottom of the fraction around and then make negative. So the perpendicular gradient of 9/2 is negative 2/9. Okay? That's huge for this question. Really significant. So again, y equals mx plus c, or minus 2/9x plus c. That is definitely going to be perpendicular to this because of that negative reciprocal instance that I have applied to that question. And it says in the question, it passes through D, 4, 6. So again, I'm going to substitute 4, 6 into this equation because I know it passes through that point. So y becomes 6, x becomes 4. Or in other words, 6 equals -8/9 plus c. It's -2/9 times 4. 4 lots of -2/9 is -8/9. Adding that to both sides gives you 6 and 8/9, which I believe, yeah, just checking, is 62/9 when expressed as a top-heavy fraction. Okay, So my final line equation here is y equals negative 2 over 9x plus 62 over 9. I've been informed that the actual answer that you're provided with isn't the same as that. Please take this as your authority as to what the answer to question 8 of this exercise is. All right? Now, just a little thing to close off here. We've got our perpendicular line equation, and this is correct. This is fine. But if I take this up here, just bear with me. Ooh, getting the camera angle right. Y equals minus 2 over 9x plus 62 over 9. Okay? Now, you might think that this is a bit messy because there are fractions involved and negatives. I could easily rearrange this equation into a form that's a bit more palatable. Let's times everything here by 9, every term by 9. 9 times y makes 9y, and then the division here gets cancelled out by this times, the division by 9 here gets cancelled out by this times, leaving minus 2x plus 62. 9y equals negative 2x plus 62, perfectly adequate. Now the fact that this starts with a negative 2, I might be tempted to just, bear with me, plus 2x to both sides of this equation. That disappears, and I'm left with 9y plus 2x equals 62. And then if I was doing A level, I'd take away 62 from both sides. It will be 9y plus 2x minus 62 equals 0. And that is a rearranged form of the original answer that we had down here. This and this, they are equivalent, they are identical. I've just been doing easy rearrangement rules that I've been practicing, for the last year or so to figure out this equivalent form. Many people consider that to be a bit more elegant, but in the end, when it comes down to it, this expression is correct. It can't mark you wrong for it. That's all that I'll be doing on this video. I might do one more on another question from this topic, but well done for paying attention. And I wish you all the best in all of your future assignments. And for goodness sake, get your work uploaded to Teams. I will talk to you very soon.